Hello all, welcome back. We shall open the previous laminar flow case and modify the geometry and case setup to match the new turbulent flow case. Okay, we shall save this as flat plate turbulent flow. Let us edit the geometry. Right click geometry and choose edit geometry in design modeler. The geometry is open. Now let us edit the dimensions to match the new problem. The domain details are given here. The overall length is 6 meter and the height is changed to 0.5 meter and the width is 0.1 meter. Air is flowing from left to right. The temperature is 20 degrees Celsius at the inlet and the plate boundary is in the bottom face. The temperature is 140 degrees Celsius. The side faces are given periodic boundary conditions and the top face is given opening condition. Okay. So we have to choose the domain height, which will be at least 5 to 10 times of the boundary layer height. So we can calculate the boundary layer height through different calculators online for the given flow conditions and the length. Okay. So the height is fixed as 0.5 meter. Next. The domain width is chosen as 0.1 meter and the actual width is 1.5 meter. You can see here. So heat flow rate which we calculate for this domain can be multiplied by 15 to find out the overall heat transfer rate. We have chosen this smaller width because we can reduce the computational mesh so that we will be able to solve with lesser number of mesh and with lesser time. Next, let us modify the dimensions based on the image given here. We shall go back to design modeler. We can change the units to meter. Let us go to the base sketch. Go back to sketching. We can change the width h1 as 0.1 meter. Let us keep it same. The vertical height will be 0.5 meter. We can come back to modeling, click generate. We shall change the extrude length to 6 meter. Click generate. Now it has generated the CFD domain. The overall length is 6 meter, the height is 0.5 meter and the width is 0.1 meter. Okay. Now let us go to Ansys meshing and create the mesh for this. Let us go back to Workbench, right click mesh and click edit. We have to click OK to update the upstream data. The model is imported to Ansys meshing. Let us edit the mesh parameters. We can see this along the length of the plate there are 60 divisions. We shall change it to approximately 100 or 150 divisions. Okay. Next, along the thickness direction we shall keep around 5 elements. That will be sufficient because we are giving periodic conditions. Next, we have to calculate the first layer height for the turbulence model and y plus which we are going to choose. We shall choose the turbulence model of k epsilon for which the y plus will be taken as 30. We shall calculate the first layer height based on the y plus 30 and the inlet flow conditions. We can search for any y plus calculator online and then enter the data to find out the first layer height. The free stream velocity for this case is 8, density is 0.83 kg per meter cube, dynamic viscosity is around 2.15 into 10 power minus 5. 2.15 and the boundary layer length is 6 meter. The desired y plus is 30. We can estimate the wall distance. The Reynolds number is 1.9 into 10 power 6, which is nothing but 1.85 into 10 power 6, and the estimated wall distance is 2.3 into 10 power minus 3. It is nothing but 2.4 millimeter. That is the first cell height from the boundary will be 2.4 millimeter for this y plus and flow conditions. Okay, we shall go back to modeler. In the inflation, we shall change the first layer height to 2.4 and the maximum layers be 30. We shall not change the named selections. You can right click mesh and click generate mesh. There is some error. The mesh has not been generated properly. We shall change the inflation layer settings. We can keep the growth rate 1.1. Now we shall generate it again. Now the mesh has been generated properly. Next we shall take this mesh to CFX preprocessor. We can close this and go to CFX preprocessor. Right click mesh and click update. The mesh is updated. We shall see the case setup in next lecture. Thank you.